So just audible. So we try to solve a few problems that we have been from the last and the before sessions. So yeah. So the two problem we are going to focus on today is the trapping rainwater problem, and the other one is the triangle number problem. So first we try to solve this one. So we already make a solution for this, but it doesn't solve the all the test cases given in this problem. And so I guess we approach it from so, so we just saw the solution of how they solve this problem. Then we try to code by ourselves. So first we try to solve sorry, first we try to understand how they approach this problem. So here we can use the two-pointed classic two-pointed technique. So to solve this problem, the time complexity they are solving is of n complexity. So to be so here as we already said, so I just clear all this out. Okay, so this is the array we have. So here 0 means there is no container, and then 1 means there is one block, and then 0, and it's go on. So here, so in order for any index in an array to be able to trap order, there must be high bars, right? So on both left and right side index, yeah, it's sure. For example, index 2 in the following array has height 1, okay. It can trap water because there are height bars to the left and the right of it. Yeah, sure. To calculate the exact amount of water that can be trapped at index 2 is, we first take the minimum height of the highest bar to the left and right of it. This is the intuition where we also solved this in the previous problem. I think uh, it's problem. Container with most water. So it means, let's say if we need to calculate the capacity of this index, which means second index. So we first need to uh, take the minimum of the left and right of that index. So here is 4 and here is 2. So then the water can store is 2. The amount will be 2. To explain this clearly, let's say this will be the 4, and then just so this is the fourth container block, and then this will be the container 1, right? And then this will be the container 2, right? So it look like this only. So this will be 4, and then 1, and then 2, right? Okay. So in order to calculate how much water we can store here is we first take the left hand side, the 4, and then take the right hand side, the 2, and then find the minimum so that we can find by this level the water can be stored, right? So that's they're saying this is the same intuition that we solved in the container with water problem. So I think it's a medium problem. So okay, we move on. So you first take the minimum height, yeah. So the highest bar to the left and right of it, which in case is 4, We then subtract the to the height of the bar at index 2, which is 1. Okay. So if we knew that height of the highest bars to the left and right of every index, we could iterate through the array and calculate the amount of water. Yes. But we don't need to know the exact height of both. The highest bars to the left and right. So I guess so we need to minus all these things to get this one because the amount of water stored is one, right? So the container has already here's one. So to know this part of the container, how much water is stored in this part of the container, so we must subtract all these numbers so that we can get 4 minus 3, 3 minus 2 is 1. So on. We just make sure. So here 0, 0 minus 1, 1 only, 1 minus 1. So here it will be 1, right? And then let's say we took here 1 minus 0, 1, and then 1 minus 2 is 1. So here it will be 1. Like this, we can do. But here they are saying, but we don't need to know the exact height of the board. Sorry, I think, yeah. So if we know the height of the highest bars to the left and right of every index, we could iterate through the array and then calculate the amount of water that can be trapped in each. But we don't need to know the exact height of the both the highest bars to the left and right of every index. For example, let's say we know the highest bar to the right of index 7. 0, 1, 2, 3, 4, 5, 6, 7. Okay. The height 0 has a height of 2. Okay, height 0. So we have highest bar to the right of index 7 with height 0, right of 2. Yeah. Okay. If we also knew that there exists a highest bar than 2 anywhere to the left of index 7, we also knew that there exists a higher bar than 2. Okay. Here in this case, 5 is the higher bar. Okay. Then we also know the minimum height of the highest bars to the left and right of the taxon. Okay, okay. So this means that we have enough information to calculate the amount of water that can be trapped in the 2 minus 0 is 2. Right, behind how the two-pointer technique can be used to solve this. Just two-pointer, the opposite ends of the array. We also keep two variables, left max, right max, to keep track. Okay. So here what they are saying is, let's say in this scenario, we just explain in our case. So here we have, let's say in this index we have two, right? Um, Sorry, better uh, we can take this as an example because we need, okay. So here they are saying, so let's say here they have 5 and then bar 1 and then 0 and then bar 2, right? So to calculate this thing, the water level in this thing, this particular area. So in the previous thing we saw that we just take the left and right bars and then subtract it with the current bar. So all we had the answer. So the water can be stored inside that particular index. But here, let's say the problem is to find out the total amount of water can be stored, right? So let's say here, in this case, this will be not the only space the water has been in the container, right? So this is the space, right? So in this all the thing, the water is there. right? So we need to find not only this particular area, but to find this also. For this, we just make sure we have a left max and then right max. So here, what this will do is, so the right we have is two, right? In the left, with the use of left max, we just store the maximum variable or the maximum number we have in this, the maximum height we have, so that we can able to calculate. We just make sure whether is there any other height that is greater than the right one or the left one, and then we can alternately do solve the uh, can help to solve the problem. So I guess we it will be clear on solving the the thing. So we just try to. So I love this thing in this site. So we just visualize how the algorithm works. So here they set all the variables needed. So we need a left pointer and then right pointer. Here is the left pointer and then here it's a right pointer. And then here will be the left max and right max and then count is zero, right? So all has been done. So the next thing is we now use the values of left max and right max to visit every single index in an array exactly once. Okay, we just visualize things. So here what they are doing is, so with the use of while loop, they first check the condition whether left max is less than right max. No, it's not. So they just decrement the right. Okay. So the first thing they are doing is, so they had initialized left pointer, comma, left max is zero, and then the right, and then right max to the length of array minus one, right? So they have count to return the total amount of water in that container. Sorry, not particular, the total thing. So the next thing they are doing is the condition is if the left max is less than right max. So if it's not the case, we just decrement the right minus or equal to one. So until this we have seen. The next thing is what is okay. So again zero. Oh, so yeah. Here they have the condition breaks. If the left max is less than right max means what we need to do is minus one and then minus one. If left less than equal to five, if left max three, here the right max will be there. Right minus one. Just missed out something. Left max and right max to visit every city index exactly once. You start by comparing left max and right max. In this case, right max smaller than. But the maximum height of the highest bar to the right of right minus one is right max. There exists a higher bar than right max somehow to the left of it. There are two possible cases considered when. Types of two possible questions where when calculating the amount of water that can be traveled, the current index of right, the bar at index, right, it's smaller than 5 max. Okay, so here is the next thing, right? So here, what we'll do is next one is if the heights of right 0 greater than or equal to 2. No. So we just count plus or equal to right max. So here what they are doing is after you're decrementing the right pointer, they just check whether the value of the right is greater than or equal to the right max. If it is so, then we just move the right max to the right pointer. Okay, or else we just count these two. 2 minus 0 is 2 only. So the count will be 2. So again, it will go on and then it goes on here. I think we just check this one. Okay, here the count will be 2, right? Uh, okay, then they just move, reduce the right. Okay, uh, just need to ask some questions. Okay, so here the key idea is the same thing. So if the left max is greater than the right max, right? So then the trapped water is depend on this one. If the left one is lesser than the right one, then the trapped water is depend on this one. So basically, the trapped water is depend on the minimum value of the left max or right max, right? So this is the key idea they are given. So the moving when it comes to how we need to move the pointers, crossing the left side means left max is less than right. Move left forward. So we just need to move the highest right. If the new height is smaller than left max, water is trapped. Otherwise, a bit left max. If crossing the right side, for this they will just try to solve. Just copy this one. Okay. So left is there and then right is there. Okay. Let's have the another L. Uh, this will be left and then this will be left. This will be left max, right max, right. So and then I just have count. Okay. So now, uh, since left max is less than right max, so here the left max we have is this is the left max 0. So here what we are doing is if left max is less than right max means we just move left one, left plus or equal to 1. Okay. So our left is equal to 1, height is equal to 1, greater than or equal to left max. Update left max. So, so what they are doing is, so we just move this to here. Okay. And then the next one condition is if the height of left is greater than left max means okay. Okay. We just move the left one. So if it's greater than the left max, we just max it out. We just move the left max to the left and then update the left max. So now the left max is 1, right? So now we again check whether the left max is greater than or equal to 1. So again we need to so it's greater than or equal, right? So we just need to move left here. So next index, right? So here, uh, I just wrote the condition. Okay. So the next what's the next one? So again, they're asking. We just again move. Okay. So yeah, the next one is so here the left value of the left is 0. So again we need to check it. If F max is less than or equal to right max or not. Um, but it's equal, I think. No, the left is not equal, so we just move the L, right? So better, I okay. So right now we are at the left max is at 1, and then the right max is at the last index. Okay, So here we just make sure whether the left max is less than less than right max. No. So we just need to move the L pointer right. So here it will be there. And then what next is right is equal to 10. 0, 1, 2, 3, 4, 5, 6, 7, 8. So I think we just need to start from the beginning to understand it. So here the left max, just write it. The left max is 0, right? So 0 is less than 1. No. So this will, what we need to do is the left, we need to move the left one plus 1, right? Here. Now, if the height of, sorry, I think the both is a variable and not thing. Okay. Okay. Now, if the height of L means this one, so now the another condition is if the height of L means here 1 is greater than the left max 0, right? Now we need to check whether the 1 is greater than yes. So we just uh, update the left max. The left max is equal to 1. So here, okay. So now, uh, the second one, right? So the second one is left max is 1 is less than right max. No. So what we need to do is we just increment the left plus or equal to 1, and then if height of uh, this one, right? Now I just move this thing. Okay. Now the height of the L 0 is greater than left max, which is 1. Now we need to check this. And then, no, so this is false. So we just count the left max minus height of left. The left max is 1 minus 0 is 1, right? Okay, now we just identify the water content in this particular thing, which is 1, right? So we just Okay. Now, now the next thing, third one. So now we just make sure that 0 less than 1. Yes. So now what we need to do is this will be the whole new point, right? So if the then here the else statement, else right will be minus or equal to 1, and then if height of r greater than the right max, then the right max is equal to height of r else count plus or equal to right max minus height of r. So now this condition triggers this else statement. So now we just decrement the r index of r, right? So now it will be decremented, right? And then next, what we need to do is if the height of r here the height of r is 2 is greater than 2 is greater than the right max. Yes. So we what we need to do is we just uh, update the right max. So r is equal to 2. So here 2. Okay. So now again we just do this thing. This the left max is less than the right max. So here let's say the left max less than the right max, right? So if this condition satisfies, then we just go through the if statement. So we just decrement the left, and then after decrementing, we just the check whether the height of the left is greater than the left max. So here, if the height is greater than the left max, then we just update the left max, or else we just add it to the count. So we just check this all. Now I think we have some clue on how to solve this one, right? So this is the given thing. So first thing is setting up all the variables, left, right, and left max and right max, and then count. So here, what we need to do is first we just check whether these two, whether the uh, left max is less than right max. If it's not, what we need to do is we decrement the right to the uh, decrement the right to the below indexes. So the right will move on. And then what we need to do the next is we just check whether the right here, the 0 is greater than 2. So the right max is at 2, right? So we just check it out. So if it's greater, what we need to do is we just update the right max. Here in this scenario, it's not greater. So we just add it to the count. So I think the count will be right max is 2 minus 0. The answer is 2, right? So count will be 2. Yeah. So the water trapped in this will be 2, right? So and then so again we checking this one and then we just move the right pointer and then calculate the right max and the right value. Again we just count it here. This will be 3. Okay. And then move right max. Now we just move the left index and then check the left and left max. So this will be the greater. So we just move the left max, indicate left max is 4, and then again we just do it. So 4 is less than 5, right? So we just move the right, left to, we just increment the left and then check the left max is already 4. Whether left is greater than 4 or not. So it's not. So just we add it to the count. So the count will be 4. Okay. So here why it's 4 by 6 is so here the left max is 4 minus the height of left is 1, right. So 3, already we have 3, so 6. So this will be the 4 by 6. And the next is so we just again we just do less than again left will be move on and then left max we just left max is 4. So we don't want do anything, just we add it to the 2. So 4 minus 2 is 2 and then 6 plus 2 is 8 and then answer is 8 7 8 and then 2 is less than 5. So move the left pointer and then the left max is 4. 4 minus 2 is 2. So 8 plus 2 10. Okay. And then yeah, that's it. So this is how we solve the problem. I think this will be a little bit tricky and confusing. By solving this, we can able to understand this. We just try to solve this on lead code. This is the last intuition we solved, but this is wrong. Right? So we just set the left is equal to 0 and then the right is equal to the last index and then the left max is at 0 and then the right max is at length of height minus 1. Okay. Now we just so the variables have been declared. So we just start up the while condition. Uh, while left is less than right until this condition is true, what we need to do. So we have two cases, right? So the first case is the left max can be less than the right max, right? So the second condition is the right max is greater than, sorry, is less than or equal to left max, right? So these are the two conditions. So I just make this as else loop. Okay. So these we have initialized the two conditions. So now in this condition, what we need to check. So I, as I already said, so let's say max is less than 5 max, right? So this will be the left max, and then this will be the right max, right? So if left max is less than the right max, what we need to do is we just move the L pointer. Here will be the L pointer, and then here will be the R pointer, right? As we declared in the variable. So we just need to move this L pointer here. So we just increment it, right? So left plus R equal to 1. So after increment it, so we need to make sure the left max is greater than the L pointer, right? So the left max, the meaning is it need to be always greater one. It need records the greatest value in the left hand side. So we just check the below options. So here the left is lesser than the left max here. So if it's lesser than so before that we just write the conditions whether if it's greater like if the L is let's say if the left max is let's say like here. So here but now what we need to do is we just move this left max to this one. So we need to just point this out, right? So for that, what we need to do is the uh, if uh, the value of left, right? So if the value of left is greater than the left max, okay. So here, sorry, I just made a mistake. It's not left. Okay, so just change the variable. So this will better. This will have the better readability. Okay, so if the left height of left here is greater than the left max means what we need to do we just left max is equal to height of left means this value will be stored in the left max. Okay, so in visualization it will be like this. Okay, so what if like this? So here the left is lesser than the left max, right? So if it is like this, what we need to do is we just add it to the count variable, but we need to minus this, right? So as I said in the previous examples, so here this will be the container, and then this will be the container, right? This will be on container, sorry. And then this will be this will be on container. We just need this amount of water, right? So this will be the water trapped in here. So we need to minus this one and then this one so that we can find out the space in here, right? So for that, we what we need to do is we just count the height of the left one minus left max. Okay. So the same logic we applied to the next case, like whether the right max is lesser than the left max. What we need to do is we just decrement the right and then check whether the decremented value, the height of right, is greater than the right max. If it is so, uh, we just set the right max to the decremented value, which is the height of right. And then if it's not, simply add it to the count variable. just this will work. Just check it out what we need. So finally, what we need to return is return the count. So yeah, we just try to run. Okay, so we have a wrong solution. So I guess this will be the problem, right? So let's say if it's greater means uh, like, uh, greatest value first. Still, the value is output is 11 and then 6. Okay. Okay, so let us solve why this problem arises. We just dry run the code we already coded. So here, so this is the thing, right? So we just copy it. Okay, so L is here, R is here, then the leftmost and then rightmost. So the leftmost is 0 and then the rightmost is 1. And then the count C is also 0, right? Okay, so what's the problem here is, okay, now we need to check whether the left max is less than left max is 0, right max is 1. So left max is lesser than right max. So what we need to do is we just increment the left. Okay. Now check whether uh, the value of L is greater than yes. So we just remove and then update the left max, which is 1. Right. So now again, so left max is less than right max. Yes. So what we need to do is we just increment the left, check whether left max is lesser than this one. No. So yeah, what we need to do is count 1 minus 0 is 1. So we just update count. So the count will be 1. So next thing, here the uh, 1 left max is 1 right. So and then left max is less than right max. No. So we just move here. So this will be greater than left max. So we just update left max. Okay. So after that, we just again we the condition is left max less than or equal to less than right max. Here the condition broke. Now we need to decrement the right one. Okay. So after moving right, so we just check whether the right max, the new value is greater than right max. Yes. So we just update the right max. So the right max is also 2. And then now, what we need to do is again check left max is less than no. So we just need to move the left to the next one. Okay. So after that, we check whether the left max is less than no. So now we just add it to the 2 minus 1 is 1. Here 1 plus 1 is 2. So the count will be 2. So now again we check these two. No. And then we just move L. Check. No. So 2 minus 0 is 2. So here the answer is 4. 2 plus 2 is 4. And then next again check these two. No. So what we need to do is increment left. Now check one is less than two. So we just add it to here. Two minus one is one. So two plus one is three. So the value is three. Right. So again, what we need to do is here. Uh, yeah. Again, check two less than two. No. So we just move the left pointer. So here, 3 is greater than 2, right? So we just modify this. Okay. So after that, what we need to do is, so again check 3 less than 2. No, sorry, 3 is greater than 2, right? So what we need to do is, we need to move the right pointer at here and then check the new value is greater than, no, it's not greater. So we just add it to the count. So 2 minus 1 is 1. So here we just add, so 3 plus 1 is 4. So again 3 is greater than 2. So we just move the right pointer. So here what we need to do is, so whether check whether 2 is less than or, so it's equal, right? So it's not greater than here. So what we need to do is we just minus it 3. So sorry, 2 minus 2 is 0, right? So what we need to do is, what is the answer? Is 6, right? So I think we need to do is if greater than or equal to. Okay, so this is the problem we had. So I didn't mention this greater than or equal to. I think it will work now. Still problem. Don't know what the problem is. What's the problem? Sorry, I just made a mistake here in initializing. Uh, Okay, so I just saw someone how to use GPT. Okay, sorry for that. So then, okay, I just closed the what? So here's my question. So here, I think what the problem is. So here, we deal this as a pointer, the left max and right max. So since it's not a pointer, it's a variable. We just need to store the value. So the length of height, the last value should be stored in the right max, and then the first value should be stored in here. So how to store the first and last value? Just height of 0 will be the first value, right? Then height of, yeah, yeah, I think it will work now. Yeah, okay. So it worked. So if you guys have any other solution better than this, so you can post it in comment sections. So I can and others also learn from your answers. Uh, this is one of the hardest problem we solved today. Uh, so if you guys watching this live can solve this, you can go and try check it out this problem container this one. If you guys can able to solve, please tell me the comment section. So you saw the answer. So you guys just try it out. So if you know, no problem. So I think we solved many problems. Okay, guys. So if you have any problems, suggestions, you can please put it in the comment section. We try to solve that problem in this live. So if you guys have any, please make sure to comment to that live. So so I do live in morning session too. So in that session, it's just study with me session. So I didn't share any screen. But I am doing some projects. If you guys interested in that, I just make sure to do in live. So if you guys are interested in the agentic AI building, the similarity search recommendation systems or any other AI related applications, so you can just comment. I just try to build a project lively. So yeah, that's the thing I need to say in today's news. So there is no comment. Okay, so no problem. I just pick a problem randomly. So I think so. Guys, use this site. It's very helpful. Hello interview session thing. So I just put the link here. Just give you guys the link. So it will be useful for you guys. So it will easy to visualize how we are going to approach the problem. So I think this will be helpful for me. Okay, so still there is no comment. Okay, so I think uh, I just took a random problem. Okay, so we move on to the the sliding window technique. So it's also a technique maximum sum of surface. So if you guys are comfortable, you can introduce yourself in like so that I can understand. So are you from uh, which college or which year or what are you doing currently? Are you working or not? So mainly are you a computer science student or just watch live randomly? We just need to know. So if you guys are comfortable with that, you can just mention that in live. So you know your just this one. Okay. Just okay. We just move on to the next one. So as I already said, we try to understand the triangle numbers. So yeah. So I think we already solved that one. But in a different approach, but we didn't able to solve all the test cases. So we just try to see the solution and then try to code on our own. So here the description is so we need to write a function to count the number of triplets in an integer arrays. So that could form the sides of a triangle. The triplets do not need to be unique. Okay, so the here the output is general. So here what the problem is say is so let's say so in a triangle there's three sides, right? So A and then B and then C, right? So if we add these two sides, any of the two sides, it should be greater than the other side. So that's the meaning of the problem. So we need to find this kind of triplets from the given list of numbers. So and then we just count how many possible numbers we can do to achieve this condition. So let's say if we adding up a plus b, then it must be greater than c. So if we adding up b plus c, it must be greater than a. If we adding up a plus c, it must be greater than b, like that. So I hope you just understand what the problem is. Okay, so someone is asking, I have a problem in logic building, how to improve that. So I think uh, for me, uh, let's say we uh, why is it that? So okay. So at first I thought the same, right? So I'm not today from today itself. I didn't able to solve a whole new problem like hard problem or medium problem all by on my own. So we just need enough practice. So the thing logic building comes from practice. So let's say here uh, the problem we had is we just vaguely approach the problem without knowing like knowing the intuition, knowing the right technique or knowing the right algorithm to approach the problem. I think that's the problem we all have when we try to solve any of the DSA problem. So let's say here we have, for example, yeah. So yeah, we take the trapping rainwater problem, right? So we already this is the last problem we solved, right? So if you guys directly go and try to solve the trapping rainwater, it's very very hard. So even though I just already solved our months ago, so I may solve this problem months ago. I didn't get intuition on how to solve that. So for that, you just split those problems based on the which technique need to use or which is the problem which supports this problem. Let's say for trapping rainwater, the container most water. So if you solve this one, you may have a small logic that comes in your mind. So how we can approach this trapping rainwater. If you solve some two pointers problems, let's say uh, the target sum, the two sum or three sum, and then the move zero sort colors. So this kind of problem, if you already solved that, so you may have some idea on how to approach the new problem, and then how to find whether it's a two pointer, whether we can able to apply the two pointer problem for this. So that's how I guess we all can build the logic. So better focus on splitting the problems based on the techniques and then solve more and more problems on one single technique. And then I guess you may solve a problem within a 2 weeks or month. So yeah, that's my approach. So better you guys try and comment the live. So I already said this is one of the most useful resource for DSA. You just guys note it down, hellointerview.com. So I love this most. So it has, I don't know, I didn't build this site. So I think someone built this. So this will also help for your system design interview itself. So it has system design and then ML design, something behavioral. So it's a like bulk of for your interview purpose. So I think this will be good resource. So here you have some two pointers, right? So just solve that. So if you guys are focusing on sliding window, just solve these problems and then move on to any other new sliding window problems. I think Yeah, this will be helpful for you guys. Okay, I think I just oh, so there are six viewers right now. Uh, so if you guys have any problem suggestion to uh, let us solve together, so you can just comment it down. Okay, so we just move on to solve the triangle numbers. So I just leave it here. Right? So we have a set of numbers here. Uh, 11, 4, 6, 15, then 18. Okay. So as I already set the conditions. So we just write on, jump into the problem on how we approach the problem. Okay. So so as I said, how to find whether the given problem is two pointer or not. So first, that's the main thing, right? So in triangle numbers, I already said if we add up two numbers, it's end up the result is ended up in the greater than the other side, the other variable number. So from that we can understand we just need to add some of the two number, and then we can using a if condition or kind of thing we can check whether these two is greater than the remaining part. So from that I just had an intuition on can be able to try the two pointer technique in here. So you guys can just try it out. So first I just place the L pointer here, then R pointer at the end. This will be the classic two pointer thing. So just place it the first one and the last one. You guys just try it out. So and then as I said, we just add these two, right? So we have the C. So here, if you guys have trouble in this on how you guys didn't know how to approach this one, so if you guys solved the threesome problem, so if you guys had solved this one, this will be easy for you guys. So for threesome, if you guys solved the twosome problem, so you guys can easily solve the threesome. If you guys solve threesome, it will be easy. So it's the basically the another version of this three sum pointer. So here what we are going to do is we just iterate I. So now I is here. Just add these two one 11 and then 18. Check it's greater than I or not. So if it's greater, just count it right minus left. So here they are given. So if it's not greater, just lower the right point or else incremental point. So I think this will be the solution. I think we already solved this one. So from by this end of this live, I think I solved enough two-pointer technique problems. Then no more. I'm going to solve any of the two-pointer techniques. We just focus on the practice of the two-pointer. So I think next of I think move on to the sliding window. This will be on. I start the sliding window problems by tomorrow. So if you guys are available or free at that time, just join in our live. Guys, again, I'm saying so there is another guy asking for logical thinking. So the saying so we don't able to think newly. That's the real truth. So if we even though let's say if I take some random problem, let's say the kth closest point, I didn't even know what the heap is, right? So I don't even solve any of the simple problem in the heap data structure. I don't even know how to code the heap data structure. So then if I try to solve this one, so it's very hard for me. I cannot able to solve a single line. I cannot able to write a single line of code in this one because I don't know any basics. So if I need to improve the logic building, so I just need to understand what the data structure, heap data structure, and then what are the techniques in there. So just solve the easy problems. So by solving easy problems, you have intuition on how to solve a newly problem. If there is a new problem given by the interviewer or any other among friends or any other sessions, so you can be able to come up with the intuition of the problem. It may wrong, it may have the greater time complexity, but that's not the problem. You just able to think how can we approach that with the existing already solved problems. So if you need to improve your logical thinking, you just need to solve as many problems you guys can. So that's the only thing. So just try to solve the easy problem so that you can be able to approach any other new problems. So that's my advice. So, so are you guys are in currently working or in college? Can you guys share it with me? So I don't know if you guys are working or so okay. So you guys, we are in live for 120 minutes, 1 hour 20 minutes. So if you guys like this live, please like and subscribe the channel so we can do the sliding technique, sliding into technique from tomorrow onwards. You guys, if you guys are free, please come and join. So we just code together. If you guys have any other tricks or suggestion or technique you have, guys can surely share your teaching or your technique or trick to solve to approach the problem here. So yeah, that's it. Thank you for the viewers.